Welcome to the Campus Energy and Sustainability Podcast. In each episode, we talk with leading campus professionals, thought leaders, engineers, and innovators addressing the unique challenges and opportunities facing higher ed and corporate campuses. Our discussions will range from energy conservation and efficiency to planning and finance, from building science to social science, from energy systems to food systems. We hope you're ready to learn, share, and ultimately accelerate your institution towards solutions. I'm your host, Dave Carlscott. I'm a director of Energy Advisory Services at Brailsford and Dunleavy.
And that kind of gets to, let's design to the 90% and not the 10%. And so if you're on a university, your job is to help educate people, I believe, right? And so how can we inspire the students? If better is possible, good is not enough. Think about what you're doing, right? Think about how can we get the most bang for our buck out of this widget.
In this episode, you'll hear my interview with Kenny Seeton, Central Plant and Energy Manager at California State University, Dominguez Hills. Our wide-ranging conversation spans everything from LED retrofits to solar-powered golf carts. Kenny talks about how to safely take risks and how to connect systems seeking continuous improvement. He offers up sound advice for energy managers on metering, sensors, occupancy controls, valves and dampers, trend analysis, and even phase change materials. While we will most definitely geek out in this episode, I think you'll find Kenny's boundless energy and creativity will keep you as engaged as it did for me. I hope you enjoy this interview recorded November 23rd, 2020. Well, Kenny, it's great to have you here on the podcast.
Hey, Dave, thanks for having me here.
All right, well, let's start out. Just give us a little bit of background on who you are and where you are.
All right, great. So I'm Kenny Seeton. I am the energy manager / chief engineer or plant manager here at California State University, Dominguez Hills. I've been here since 2011. Ironically, I never thought that I would end up at a university like this. I spent 27 years working for Hostess Cupcakes Twinkies and really loved what I did. Heard about this job for 5 years because I replaced one of those chief engineers that was going to retire forever. And the first 3-4 years I said, nah, why would I want to go there? That's got to be the boringest job in the world, just running fans. Turns out that, after 27 years, even I started thinking it was time to get off a graveyard. So threw my hat in the ring, got the job here, and who knew that, I had died and gone to heaven, that this job was really designed exactly for me.
That's interesting. I didn't know, I think you'd mentioned the hostess background, but I didn't realize you'd been there that long. Were you working in facilities there, or what were you doing?
Yeah, I started off as greasing equipment, worked my way up to the assistant chief engineer. So I spent like half of my career there on the floor and the other half as the assistant chief engineer. But in the manufacturing world, as lean as it is, I was on the floor working whenever something needed help. The beauty of that career or education that I got, and instead of waiting for, where'd you go to school? That's where I went to school, right?
Right.
Because I was there on graveyard, if I couldn't fix it, then it was 3 hours to get somebody in there at 2 o'clock in the morning to fix it. So it really taught me to be self-reliant and to work with what you had. I think that's a big part of what got so exciting about what I do now is that, how do we make all these things work together? How do we solve these problems? I spent my whole growing up career solving problems. When it's $1,000 a minute, when the line breaks and there's 30 people standing around, there's a lot of pressure. So it's the same thing now, right? We're spending millions of dollars on electricity. How do we solve that problem? How do we reduce that greenhouse gas and that kind of stuff? So it's just fun.
Oh, that's great. I had a former career in software, and a lot of the systems I would build would if they broke, the business went down. So I at least know it wasn't a production line in the physical sense, but I at least know the stress and the learning that occurs very quickly when you have to put yourself in that situation. So that's great. Well, tell us a little bit about your job now. So you obviously enjoyed the switch, but tell us a little more about what you're doing at Dominguez Hills.
It's funny, when I started working here, the director of facilities said, your job is to make sure that I don't get as many hot and cold calls, people are comfortable, and that your employees get paid. And I said, yeah, but I'm the energy manager also, right? Look, I want you to just focus on that. Focusing on making sure that everybody's comfortable, hot and cold at the right temperature just leads into energy management, right? Because we have systems that aren't working correctly. When we fix them, we save energy. It's really simple, right? And I was faking it for the first forever. We all think that, are they going to wake up one day and say, this guy doesn't know what he's doing? But obviously I think I've done a pretty good job, But when I first started, they were doing a MBCX, monitor-based commissioning project, and it had been going on for like 5 years. They handed me this punch list, 6 pages, this Excel document with 6 pages of things to fix. And I looked at it and I'm like, oh my God, what do I do with this? And I asked the director, I said, okay, so what do you want me to do with this? He goes, fix it. You go, so this thing that says thermostat behind the coffee pot, I could just move it? Yeah. This thing that says valve doesn't open and close, there's a pair of vice grips on it. Can I buy a new valve and an actuator? He goes, yeah. This economizer that's stuck, you're saying that if I just unstick it and put a new controller? He goes, yeah. And I go, oh, that's not rocket science, right? So I went through and I just fixed all these things, and the building saved $100,000, in rebate money the first year. And I'm just like, wow, this isn't that hard. And in fact, it's kind of cool, right? Because now you see all these components that make up what does it take to keep a building comfortable. And then it just kind of advanced from there. So that's how I got into it and started getting excited about it, was that first punch list.
No, it's funny. I often will say that people just don't really care about energy or think about energy. And it's not that they don't care. It's just that it's not something that they just take it for granted until it's broken. But it sounds like you got to go in and basically get rid of a bunch of niggling problems people didn't really notice all at the same time.
Well, the thing that's hard about in my peers and chief engineers and stuff is that honestly, if nobody's complaining, there's not a problem. And I don't mean that there's not a problem. It's just that we have so many other things that we have to deal with.
Right.
And so if nobody complains about it, good chance it's going to stay like that for a while. So until you really start looking at it and that's where that energy efficiency side, it gets you in there to fix all those problems. And then you realize, oh my God, you know what? There's not really half as many calls. Chief engineer or the director of facilities is like, wow, Ken, I used to get complaints all the time. And when they get to that level, that's pretty bad, and he's like, they've gone down, exponentially. And I'm like,
right.
Okay, so that's how you can tell I'm doing my job. And the utility bill is getting better and better. We save more money every year. So
yeah, well, how did you go from that? I mean, fixing thermostats over coffee pots is one thing. I mean, it's actually harder than it seems sometimes just to get people to track it down and actually get somebody in there to fix it and have a process by which it gets fixed. So I don't mean to undercut the difficulty of that, but when you've done all that stuff, then you've done a lot more than that. I know now. How did you move to kind of phase 2?
So I think phase 2 was, it was exciting, right, to see these results, right? And then, but even in the early days, we really couldn't see them the way we wanted to. So then we started getting into metering, right? So that was the next big thing. And when I first started doing metering on these buildings, I didn't realize that everybody thought, oh, you just put one meter on the building and that's great. Well, the problem is with these older buildings, every transformer needs a meter. And I've got buildings that have 4 transformers, right? So all of a sudden, instead of this $1,000 meter, it's $4,000. And instead of just, okay, this weekend we're going to do this, but I just took it one step at a time, and I think a lot of that, even going back to Hostess, right? It's like, what can I do to fix this problem right now instead of waiting? I can't wait, right? And so
right.
It's the same thing, right? So instead of waiting for somebody to give me $1 million to put meters on all these buildings, I said, wait, I can put 1 meter on now and see a fourth of the building. And so every month, if I had money left over on my credit card, I bought another meter. And when I had 3 or 4 meters stacked up, then I scheduled time with the electricians. Hey, let's install these meters. And I spent a couple years doing that, right? Until all of a sudden now I have electric meters on all these buildings. And then we can start really seeing, some cool stuff. With the CSU, we have a working group, all the energy managers. There's 23 CSUs. And we used to, before COVID, meet in person, a couple times a year. Now we have our monthly phone calls, but we share ideas. And for me, it became competitive because when I first got into the system, there was some really great guys, at Long Beach and Fullerton and Northridge. And I was like, I want to be a rock star. I want to do that, right? So I'm listening to what they're doing. We're talking about lighting and stuff. And back then it was still fluorescent. Nobody could afford LEDs in 2013 or so. And then things just start coming across your desk. I learned about this great control software, Enlighted, right? And I'm like, hey, let me try that out. Oh, that's too expensive. I'm like, well, I'm just going to do 1 classroom. I'm just going to do 5 offices. And that grew, and I worked with them. And then it was something else, and then it was get involved with the U.S. Green Building Council and There's these projects. I made connections with my local utility, Southern California Edison, and worked with their emerging tech. And it's like, hey, we want to do, have you ever heard of these Belimo smart energy valves? And I'm like, actually, yeah, I did hear about them. Well, we'd like to put in 6 of them and test them. Like, hey, I'm the guy, right? So I don't know that it was like this plan as much as it is the more you do, it's karma, right? It's you start doing these good things, people start hearing about them, you start hearing about more. If you look at my LinkedIn presence, I try and share the things I'm doing, and that helps people to reach out, and I find new stuff.
So it really wasn't phase 1 and 2. It was more like one thing to the next, one fix to the next thing.
I wish it was phase 1 and 2, because then it would be an 8-hour day, I think, right? Work on
right.
Work on this. Instead, it's like if I see something that looks. So the tagline on my email is if better is possible, good is not enough. Right? And
I like it.
And so I look at things like that. I'm always like, okay, yeah, it's good, but if we did this, it'd be better, right?
Right.
We did an energy managers meeting, and there was this. I remember this young kid came out to talk. They would have guest speakers sometimes, and back then the company was Ecovox, and they had this analytics software from SkySpark, and they're like, hey, we can do this and this and this, and I'm like, and I asked him a couple questions. I'm like, okay, well, who owns the data? You do. Yeah, but what happens if we get divorced, right? And your company doesn't work. Mm-hmm. He's like, well, you could host it on your site. It's an open source SkySpark, and I could give you the name of 3 other companies right now that program in SkySpark if you didn't want to do it yourself. Why would you not test that out, right? It's like there's no risk. The money is minimum at that time, and turns out that they went from that to SiteLogic to everybody's using them now. And it's like, so it's reaching out and finding people when they're young and new and entrepreneurs and that kind of stuff is really exciting also to me, because I love to solve problems. And in the early stages, there's lots of problems, right? But we have our own problems, and if we can steer that technology to fix my problems and everybody else's. I forget where the question was, but that's where I'm going,
Well, no, I was just saying you didn't really go from like, phase 1, fix all the easy coffee maker thermostat problems, and phase 2, meter every building, and it was more of a organic process, it sounds like.
Yeah, I think I went from like year 2 of my career here to like the next 7 years haven't stopped, right? They're just like, just exploded, right? And it's just, there's always something new.
So one of the questions I'd have, though, this comes back from more of my software days, because I think that describes a lot of what we did in the software world, which was, you'd build something and then you'd add on features to it. And then before you knew it, you had this Frankenstein system that nobody could really run anymore because it was like all this stuff kludged together. How do you avoid that kind of situation? Because, so you're talking about physical systems even, so it's even probably worse, or that the implications of it being thrown together like that could be more dangerous or damaging or threatening. Right. But anyway, go ahead.
I don't know that it's that big a deal really, right? Because if we take intelligent risk, right? We look. So let's talk about the Enlighted, right? So the first thing I get asked was, I actually got told it's better to die with the herd than to die alone. Right, when I was testing this stuff out. Right, and I'm like, well,
nobody ever gets fired for buying IBM. I think is the expression that I used to hear all the time. Yeah,
different. Yeah, exactly. Right. So I'm like, well, okay. So here's the worst case scenario, right? I'm only going to do 10 of them, and if they don't work, I unplug it and the lights work just like they always did, except for I'll have new fixtures in there, And so there was no risk.
Right.
And as we develop that out, it gets better and better. It works by itself. Software, if it works correctly, you don't need somebody except for when somebody changes out hardware, then your software stops working, right? But in general, it kind of works.
Right.
We put systems in that, we have redundant backup. So even if the software fails, it's like I call IT and say, hey, can you load up yesterday's backup, right? And things go back to where they were. And then once that's working correctly, we say, okay, what's the next step? Well, let's link that to the building automation system, right? Well, my building automation system is solid. It's just a point that I'm bringing into it. It works or it doesn't work, So once we take the time to make it work correctly, I don't do anything anymore, right? So my goal is to design a system so that when I leave, it still runs, right? I get so tired of people saying, well, yeah, but Ken, what happens when you're gone?
Right.
When I'm gone, it's still going to be running, We have a 4 megawatt hour STEM battery storage system here, designed for peak demand shaving. I do nothing, right? The system is in place. It's on the main infrastructure. When there's an event or when it sees my electric bill start going up, the thing automatically works, whether I'm here or not, right? Later, I'm going to add more batteries.
Right.
The other batteries, maybe they'll take some more tinkering and stuff, but I'll still have that one big system that's going to just work. We put in the Belimo smart energy valves, right? Once you get them programmed correctly, they're just a piece of hardware, just like we had before. Old school people, mechanical was good, but once you take the time to prove it and make it work correctly, there's not a lot of work left over after that. That's the whole idea of creating this new stuff,
Right.
is to automate it so that we can go spend time on fixing the stuck dampers that no matter, how many times we go over there and fix them, it's like in 2 years, it's like, how come the dampers don't work anymore? No amount of technology is going to fix that for us,
Right. So but I like that. So you're basically making little modules of functionality, like, back to my software analogy. I mean, that's kind of how we would do it too. There were pieces like the login screen. We built that 5 years ago, and it's still the same login screen. It hasn't had to change because it doesn't need to do anything other than log you in, and that hasn't changed
Correct.
at all, right?
Correct. So we make sure that the module works correctly, and then it's just finding that link that links it to the next piece of software, or in our sense, the next piece of hardware, right? Only
Right.
now we're getting to the point where it's really software and hardware, right? So how do we connect those two?
Well, as you think of your peers, how many of them do you think are operating that way? Like, so it sounds like your job then is the innovation of like getting the next piece of the next widget or collection of technologies to work together versus hand holding the system that maybe be held together with baling twine and bubble gum or something like that.
I want to think that they're all trying to do that, right? Have to believe that, right? But I think it's hard because a lot of them are just energy managers, right? So if you're just an energy manager, it's hard for you to look at how that stuff integrates because you have to work with the plant guy then, right? Or the trades and stuff like that. And so you got to form that link. I think that most of us are looking for that magic bullet. Okay, well, I'm going to put this lighting stuff in. I'm going to take care of that. From an energy side, I think a lot of them look at it just from the lighting side and not from the whole building side. And I think that's where we need to get better as a system, right? We need to be able to holistically look at it instead of that one piece. Well, they tell me if I put this piece in, then it saves whatever. Let's call it a Belimo energy valve, right? It's going to save me energy because I'm going to use less water, blah blah blah. And the energy guy sees that, but he has to sell that to the chief engineer. But he doesn't know all the pieces. So if they're working separately, it's complicated. Whereas realistically, if you told the chief engineer, yeah, but if you put this valve in, it's going to cost the same as a competitor valve, but it's going to tell you what the GPM is all the time on your air handler. So when you start to go troubleshooting, you're like, the air handler doesn't work, but the system says the valve's open. You actually know that there's water or not water flowing through that. And that's how it was with all the older stuff. And so there's this connection that has to be that we have to create so that my peers can do their job better, I think. And I'm not saying all my peers, right? There's a lot of us doing great stuff. The CSU is a really exciting place. We share that. But the sustainability, the energy, and the plant have to be a marriage, right? They all need to be connected because they all have that thing that they're really good at. But, just like a good marriage, right? You have a happy marriage if you're both really good at things and you combine those efforts, right? So it's that symbiotic relationship, right? Everything is getting better instead of just this section.
Right.
What are the strengths of the different individuals? What do they bring to the party? And are they all working towards that same goal, right? Which is where we all need to be going, right? How do we reduce greenhouse gas?
Yeah, no, I appreciate that. And you can tell in the way I framed the question, I've run into a lot of people that seem to kind of not make those connections. I mean, often I'll meet people that are focused on making the buildings work, making sure they're reliable, but they don't really care about the energy. The energy is a means to making sure they don't get cold and hot calls, right? Like they'll just turn a fan up or, turn the thermostat up more or down or whatever. So having that connection between those two things is, I guess I hadn't really fully appreciated. Most energy managers are not necessarily engineers.
Right.
I mean, not necessarily. It depends on the organization, how they're structured, and how that all fits together. Oh, that's great. Well, let's talk about some of the specific systems. So in your intro, you basically talked about the fact that you were given authority to go fix stuff, which I think is great. I mean, that's like, if you don't have that, you're kind of stuck, right?
Well, and that's the beauty of being the chief engineer, right? Because if I was just the energy manager, limited budget, no manpower, how do I go out and fix this stuff? But as the chief engineer, it's like, I have a half a dozen guys to a dozen guys working for me. I'm like, hey, fix that, and here's the budget to fix it. Anyway.
Well, and it sounds like your motivation largely is to literally fix it, not to save energy. Like the saving energy is a second. It's not that it's not important, but that's not really the primary thing you're doing. You're actually trying to get the building to work, just in the generalist sense.
In the beginning, yes, it was so funny. I spoke to the dean of whatever. He was our sustainability committee, and I went in and told him one day. I said, look, you know what? I don't get the sustainability stuff. I'm not really into that. I'm into saving money, right? Not realizing that early on that if you save money, you're into sustainability, right? Because if you do it correctly, it's that whole thing, and that's let's fix the problem and save the environment at the same time.
Right.
Those are the solutions that we're looking for.
No, that's great. Well, let's talk about some of the more advanced systems. So you did mention you doing a lot of metering, like of your campus. How much of your campus now is metered at what level? Just talk to me a little bit about how that system works and how do you operationally use it? Like, are you looking at reports every day, or just tell me about that?
No, I wish that's all I had to do was look at reports every day. Haha. But no. So every single building on my campus now, with the exception of I think 2, have electric meter data. I'm working on bringing the water meter data in next. I've got a couple buildings. I've done gas meter for all the buildings, and my goal is to stop burning gas. So we'll see how we'll talk about that a little later. So
okay,
every building has an electric meter. That electric meter is brought into, we're a Medicis JCI campus here, so all that data is brought into that. From there, every single trend that we do goes into the Ecovox SkySpark platform. And then we're able to do trend analysis and look at this stuff. The biggest thing that I use it for is proof that I'm doing the right thing, that we've done the right direction. And the second is it helps me to do more pilot projects. If it sounds kind of funny, but it's like, I have this great data. Why don't you bring your new emerging technology here? Let's test it out. I'll give you access to the data. You can see what's going on, and there's complete transparency on how we're doing this. So that's what I use. Right. I use it as much for that as I use it for troubleshooting, realistically.
Interesting. Okay, so yeah, you're like the tracks in Michigan where they try out the new cars or something like that. For your campus becomes that for the private sector.
That's my hope. Yeah, exactly.
Huh. Okay.
And then let's look at technology. Then that is, how can we test out this and not risk shutting the campus down?
Right.
Anyway, that's a whole nother side of it, but I don't think that's as scary as people think, realistically, right? Because, if you think about the software, even from your world, right? If you wanted to try out some new thing, you wouldn't overlay the entire medical hospital's software. You would take one module that was offline on a private computer and you do that. Okay, well, campuses or high-rise buildings have so many of these smaller systems. Okay, well, I'm going to do one classroom. I'm going to do one office, I'm going to make these adjustments that I can push a button that they go away. And so the risk is very minimal for this new stuff.
You often will hear about how universities are like the place where new ideas come and they're so innovative and all these things. But in practice, at least in my work as a consultant, they're some of the stodgiest, like risk-averse kind of, old school. I mean, the organizations that have been around for hundreds of years and will likely be around for 100 years because they move very slowly. So that's a good point. Like you're able to do this down at the module kind of level or at the building component level rather than, changing the whole system. But over time, that stuff adds up.
It adds up, and then it proves concept, and it let's do something bigger. Good track record, and you just keep going. And I understand that I'm lucky that I'm at a small, medium-sized campus. One of the very large research institution hospital campuses, there's a lot more rules in place that they have to deal with. But I still think there's things that they even can do at a smaller level to help promote this stuff. And they do it, but maybe they just they don't talk about it as much.
Right. Yeah, you probably have a little more leeway because people aren't on ventilators, or if biological research going on that could kill people if the energy goes off, right? Yeah.
Exactly. Destroy 20 years of somebody's research or something like that.
Exactly. Yeah. No, that's interesting. Well, okay. So we got metering. We've got what else? It sounds like lighting. Are you pretty much through your lighting projects? Tell me more.
So first we did metering, then we got into lighting. I played with different stuff. I've chosen lighted to use at this campus. And I'm not saying it's for everybody, but it worked here. The first time I tested it, I did 4 sensors in the hallway outside of IT, right? That was how I proved concept, right? If IT is okay with it, if it's outside. And then so that expanded to classroom remodels. We did 4 classroom remodels over the summer. Okay, let's put it in there and try it out. And then that went to, okay, well, let's do all this exterior stuff around this building. And then, all right, hey, let's do a whole building. Wow, this went really good. Let's do another whole building. So it was great because not only did we turn down the lights and save a ton of energy, but then we were able to finally this year tie it into our building automation system. And now we don't have to cool spaces that don't have people because now we know that there's no people in there. So we're able to change our ventilation rates and do all that. So lighting was probably the next biggest thing that I really got into that was exciting.
So, but let me stop you there. So you're saying that because the lighting occupancy sensors existed, then you could use it for other systems. So it wasn't really just lighting. It was like lighting, but
correct.
Smart building technology, essentially.
Yeah. So I probably started playing with the controls before I started playing with the lighting, right? Because LED was too expensive when I first started playing with it. And I was an early adopter on the controls. As the controls got better and LED got more affordable, as we expanded, it just kind of worked together, right? And then the controls, as they got better and better, then the next step was, because for the first 5 years, I didn't tie it into the building automation system. It wasn't until they were ready so that we could do something with the backnet to pull it into the building automation system. And even then, it didn't work on some of the buildings I did because those buildings were pneumatic. They weren't even DDC or digital, right? We couldn't control them. But I like to think that I chose a product that I saw the future, right? I saw that, well, eventually these pneumatic controls are going to be replaced and I'm going to be able to gain control of this stuff. Eventually I'm going to want to control the ventilation and I need something, why would I want to put in another occupancy sensor if I already have that built into this one?
Right.
And so I looked at that product as, okay, well, let's look at it 5 years out, right? Not just today. And it was a gamble, right? I had to hope that company would stick around that long, and I got lucky. So
I guess I hadn't really thought about this before, but I mean, I've done a lot of modeling on lighting projects, and you always, adding controls is another way to try to get the payback to make sense. With LEDs, it's hard because they don't use very much energy, so turning them off doesn't save you as much energy as turning off a crappier light bulb. So the controls kind of got value engineered out of a lot of projects because of that. But what you're saying is they're not really for the lights; they're for the rest of the building. So that's, anyway, that's a takeaway for myself that I'm going to log away here.
And I've got some really awesome graphs that show, just the where's the KW, KWH before the lighting, and then with the lighting, and then the controls got tuned and it dropped down, and then they got brought into the building automation system, it dropped down even farther. And then it was 6 months later that I had another issue where, we had that override. So in case, talk about what's the risk, right? Well, the risk is what if it stops working? So we had a switch built into the building automation system that would just disable all of that. And so if we disabled all the control section, then everything went to fully occupied. And that got flipped and I couldn't figure out, I saw in the graphs now, my chill water usage went up. Mm-hmm. Because if all those buildings are occupied now, or the one building that we were, demoing it at, all of a sudden everything went up. Well, my chill water doubled to the air handler. Okay, so now multiply that times all the buildings. So it's so many things. You look at it just from a KWH, but it actually, all these little things that we do come back to the central plant, to the air handler, and that's where the Belimo smart energy valves, because now I actually had a GPM meter on every single air handler. I was able to pull that graph in and say, wow, you know what? When the building was 6 people per floor and Enlighted was talking to my building automation system and I had all those zones shut, I was doing 20 GPM to the air handler coil. And when we accidentally flipped that switch to occupied, I went to 40 GPM.
Wow.
Right? And so how much more of a load, how many tons is that coming off of the central plant?
And a lot more than your LED lights, that's for sure, right? Yeah.
Exactly. So it's not just that I was able to, the LED lights were easy. The other thing, not to get into the whole control thing only, but we changed out fluorescent bulbs, put in LED bulbs, and 70% of them are at 40% or less when we got done. If you don't put controls on there, it's hard to adjust the lights to the individual user. So now people are happier because we can turn their lights down to what they want.
Right.
So that's a whole lighting thing, right? So
more about lighting quality than it is about the energy, right? In that case, you're again fixing it as the engineer, not just saving energy as the energy manager.
Yeah, exactly. So all right, so we did the metering, we did the lighting, we did a 4 megawatt hour stem battery storage system. It was done through LCR, local capacity reserve. So again, I'm working with my utility rep, working with different vendors, looking at different things. Batteries are the next evolution, right? If you think about, the entire city, whatever city you're in listening to this, everybody has solar on top of their roofs. And we have all this free electricity, and all of a sudden there's some crazy storm out of Alaska that blows all these clouds over us, and all the solar reduction goes to 20%. Okay, well, where's that power come from, right? So that's where the batteries, I think, are so important. Instead of having, coal plants or peaker plants having to fire up or having to sit on standby all the time so that we can do that. And so batteries were the next thing for us. Let me step back so talk about a little bit about who I am, right? So we started playing with batteries and solar. We started putting solar panels on our golf carts because, again, we're playing with this. Practice what you preach, walk the walk, talk the talk. My first solar system on my house was a plug and play system from Amazon that I put on my own house, right? And then Jeff Morrow, the guy that works for me, supervising building service engineer, he's like, "Wow, Ken, it's really that easy." Yep. And we redesigned it and did a better system for his house, So then we're like, well, look, it's that simple. Solar panel, a battery, So then we took a golf cart and said, hey, what if we put a 300 watt solar panel on this golf cart? The golf cart doesn't have to be plugged in anymore,
Right.
So then it's like, wow, the solar panels, the batteries, all right. So then as I'm, not that I wasn't, but, we're talking to battery people and that kind of stuff. And it's like, oh, I know, I get it. I really get it. We were probably 3 years ago one of the largest battery storage behind the meters that wasn't commercial,
What's your peak load on a daily basis? Just what does 4 megawatt hours mean for your campus? Like how much electricity does the campus use?
So it's funny. So 4 megawatt hours actually means, because of what my load curve looks like, means I can shave about 300 kW off of my peak throughout the day. It means that realistically I could do a whole megawatt for 4 hours, right? If I turn the battery on full blast, so from 4 to 8 o'clock, peak time 4 to 9. So from 4 to 8, I could reduce, if I was doing 2 megawatts total, I could go down to 1 megawatt for 4 hours.
Okay, and is that a pretty normal peak for you guys on a regular day? Like maybe?
Yeah, we're before COVID we were 3.5 maybe, and the battery kept me at 3.3, something like that. Right now COVID, the battery's got me down at like 1.3. I'm 1.5, 1.6 before the battery. We're just turning things down and not cooling the spaces where people are not at that kind of stuff.
Right.
And it's about $60,000 to $80,000 a year savings is what we're doing because of the battery, because peak demand chargers are so high. So if you look at like $17 a kW times 300,000, that's a good little amount. 300 kW. The battery was kind of the next step. It's doing wonderful. I guess the Belimo smart valves were kind of another thing that we once we saw all of the benefits, not just pressure independent and set the delta T to what you want, but hey, look, I really can see what's going on in this building. We just finished installing the last one about a month ago. We're working on the commissioning and getting them all brought in and talking correctly. Once that's done, we're going to actually control the secondary pump that pumps the chill water throughout the campus. Instead of adjusting off of pressure or delta P, we're going to adjust that based off of open valve position, right? So now that I know that, let's say that valve's calling for 75 GPM and it's getting 75 GPM and the valve position is at 40%. Hey, I'm pumping too much water, right? So I can start slowing the pump down and saving more energy on the secondary pump. A lot of people run things because that's the way they've always run and we don't get any complaints. I'm finding that out. I started tweaking things for demand response, and I found out that, we run 14 dp differential pressure on the secondary pump. That's about where it runs. And when there's an event, I turn it down to like 12, and everybody's still cool. And I started one night, just start turning that down, and I got it down to like 6 dp, and the spaces that needed to be cooled at nighttime were still cooled. The police station and a couple of server rooms. Yet the controls were set up so that the minimum it would ever run is 12, right? Because people that's the way it works, and no complaints. And so it's those little things, that we start having the visibility because of the controls or because of the metering, because of the valves correctly, we can start seeing that, hey, we're doing way more than we need to. We can turn these down. We can turn these lights down. We can turn these pumps down. We can turn these temperatures down.
Right. I was talking to somebody who is an energy manager at a campus, and they were talking about how they used to just like pre-cool their chilled water loop like in the morning when they knew they were going to have a hot day, and they would just get it super cold because they didn't have an energy storage tank, but they knew that if they did that, that they wouldn't have complaints during the day. But what it sounds like you're doing is, it's rather than thinking of the whole system and just like overpowering the whole thing, you're having much more granular control along the way, so you can see where you can make those adjustments. And I think that's, again, making it work better, which is awesome.
Right.
So.
Instead of doing his entire loop, if he had the controls on the buildings, he could, not every building has the same thermal mass as the one next to it, right? So it could be that instead of pre-cooling his entire loop, it's just like, I know that I have, the 1 or 2 buildings that are a problem now, and I'm going to pre-cool those buildings, not the entire plant, not the entire campus. And that kind of gets to, let's design to the 90% and not the 10%. And pre-cooling the loop for the whole campus is because we're fixing like the 10% right? issues, right? Yeah. So we should be designing to the 90% and then customize to the 10%. And we can talk about that more. I really think that's really important that people grasp, especially when controlling buildings for lighting, temperature, starting up, all that stuff, right? Yeah, there's that south-facing southwest office that has all windows that I can't do a 5 or 6 or 8 degree setback, because as soon as the cooling shuts down, his office gets 15 degrees warmer, right?
Right.
But I can adjust his office differently, right? As opposed to all the interior spaces that they recover just like that if my system is working correctly. And so I'm going to adjust those spaces, and then I'm going to customize the 5 or 6 or 10% that need that more. And that's how we're going to get better energy efficiency.
Yeah, like your lighting, you said earlier, if you have the controls on the lights, then you can actually set the light to the level that the people want it.
Right.
Rather than just like turning the lights off in the entire floor or something like that. You just have much more granular control. All right. Well, okay. So we've been through metering, we've been through lighting, we've been through the cooling system, been through the storage, battery storage, which is great. You mentioned trying to get off gas. So tell me more about what you're doing there, because that's obviously the holy grail of at least the work I'm working on with decarbonization planning.
I really do. I hope that it is the holy grail. So we've been working with a company, Solar America Solutions. They have a vacuum tube solar thermal system that is supposed to be 4 times better than what else is out there. And so we're right now piloting their product. We've put 3 15 panels up on the roof, and we're going through the commissioning stage now, trying to get the flow just right and all that stuff. They've got this product in one spot in Indiana where they've got a bigger system, and they're first going through a heat exchanger for an air handler, and then from there it goes to a domestic hot water loop, and then from there it goes to a swimming pool, right? And so they're heating all this stuff with just the sun. And so if we make this work the way that they say it does, and that we hope that it works, I don't need boilers anymore, right? Because we can get everything from the sun. Put a few, 150 of these, but we put a few of these. We have to find the real estate for it, and then we just dump it right into the hot water loop. Now that takes care of the daytime stuff. So if we size the system correctly, my next step, because to me it's all about marrying 2 different technologies, right? So there's another company we've been looking at called NovaCab that has this stuff called phase change. Think thermal energy storage, right? Instead of a big hot water tank or a ice water tank or ice, they have their special recipe phase change material that we can design it for hot water or for chilled water. I think that right now we should be putting all our efforts into hot water, because I don't care if I shift my energy load. I need to just stop burning gas. That's going to be the biggest bang for all of us on greenhouse gas. And so instead of putting this 1 million or 2 million gallon tank up on the hill next to the campus, I don't have the real estate. It comes in like 3 foot by 4 foot by 4 foot pods that I could modular put together. And we're lucky that we have a tunnel system here at my campus. I want to line the tunnel with this phase change technology, take the solar thermal, charge up the phase change. At nighttime, the phase change continues and keeps my loop warm. And in a perfect world, I design the system big enough for the winter time, and then in the summertime, I take that excess heat that I'm storing and I run a Rankine generator, hot water generator, right, that creates electricity. That would be the holy grail that would continue that whole loop. I'm gonna find out.
So so let me say it back. So first of all, the phase change material, I guess what I've heard about phase change material has usually been designed inside the building space directly, if like beams and cooling beams.
So that's one style, right? So they have this phase change material that you put like in the attic or the ceiling, right? So it absorbs the heat, doesn't let anything come through. There's another stuff where it actually is just, think about a big cube of Jello, right? That you could charge it up with hot water, and then it absorbs all that heat and just stores it there. And then when it's needed, you run your cooler water back through it and take that heat back out of it. So it's kind of like ice.
Okay. So it's essentially like ground source heating, but you're not drilling into the earth. You're just running it through this Jello-like material. Does it actually go from like liquid to gas, or like when you? Tell me more about the physics of that.
And I'm not an expert on this, but it kind of goes from a solid to a liquid.
Okay.
Right. So as it absorbs all that heat, as it goes away, it changes state again. Same thing whether you do it for chill water, and it's a different recipe if it's chill water or if it's hot water. You design it for the temperature that you want to run. If I want to run 160 degree water to the campus, then I would have it designed at 160, charge it up, 180, add all the heat into it, and then take the heat out just by running the water across it. The beauty of this is, if it works, is that there's no moving parts.
Right.
So the solar thermal, all I got to do is pump water up to the tank and a heat exchanger. The phase change, all I got to do is pump water through it. And if I line the tunnels and put it, have all my hot water and chill water lines throughout the tunnel, then I don't even think I need extra pumps, because I'll just use the main secondary pump and just divert the water when I need it through it. So you'll have some Belimo valves, right, that are opening and closing that are letting to control the temperature. And so you don't have that thermal problem that you have with,
stratification in the tanks or whatever. Yeah,
exactly. Right. I don't have to create a false load, because if I bring my temperature back at the wrong temperature, then I lose all that. So I'm wasting energy. So low delta T problems go away, whether it's hot water or chill water. And so, it gives us a lot more flexibility on what the temperatures that we run our campuses and our loops at.
So, but it sounds like this is a good solution given your climate, given the fact that you guys are not on steam, you're on hot water, right?
Correct.
Yeah, because if you were on steam, this wouldn't work.
Yeah, we used to be steam years ago.
Okay, so you still have the steam tunnels, and that's where a lot of this would go?
Yep.
Okay, interesting. Okay, that's good. This gives me some good ideas. And then you're saying in the summertime, you'll have too much heat, so you can use it to run. That's where the Rankine generator would come in?
Yeah, that's the hope, right? I've done a little bit of research. I know it's new, and, obviously, hopefully I'd find funding for some grant, some CEC grant or DOE grant or something like that to help pay for this kind of stuff, because it's not free.
Right.
But somebody has to be it. And so I'd love to be the first guy, so let's try it out.
Yeah. Interesting.
Again, what's the worst case? It doesn't work and I still have my boilers as backup. But I'm not going to do this until I've done, we're doing 15 to 20 of these solar thermals before I do 150 of them, right? We're going to make sure that the numbers are correct. And the same thing, we'll do 2 of these pods for the phase change and make sure that we get the right BTU content in and out of them like they promise before I buy 60 of them.
Yeah, what's just a couple, like how efficient are they? I mean, like you put in heat and some of it's not going to come back out, but how much do you have numbers on that?
I don't remember. I don't remember what the numbers were.
Yeah, but it's in like high 80s or the 90s, that type of range. Yeah. Okay.
Yeah, because there's nowhere for it to go, right? So it's sealed up in this container. It doesn't leak the heat out. So, and if we're making it from the sun, then we can afford some losses. But from what I remember, the numbers are pretty high.
Interesting. Well, that's exciting. So it sounds like you've got your basics in place. You've got your metering. You've done your lighting. You've got a bunch of different controls and improving all the time. This phase change material that we just talked through seems like pretty promising stuff you're already testing out. What's next? What's next on the design board that you haven't really implemented yet, but that's on your list?
So one of the things that I'd really like to do that I've reached out to a couple people I'm trying to figure out is the whole vehicle to grid. Only for us, it would be with the golf carts, right? So we've done the solar panels on top of the golf carts. We've proven that, I've got golf carts that are 8 years old with the same set of batteries in them, and nobody plugs them in. And so that's great, right? But that means that batteries charged up and have a 300 watt solar panel up there just wasted. If you count up how many golf carts a large university and all these places have, it could be 20, 50, 100 golf carts. And if every one of them had a 300 watt solar panel, now instead of just parking it wherever, at the end of the day, if the person plugged it in just like they would have done before the solar panel, and we put a bidirectional charge controller on that. So now once the batteries are full, that 300 gets into the grid and we reduce. And if we put a communication, some kind of Zigbee or Wi-Fi or something in that controller, then at 4 o'clock or the next time we have to worry about brownouts, hey, look, I got 50 golf carts that all have XKW on them. I could reduce for an hour and help with the peak. That's something that I'd really like to see happen. I know we're starting to talk about it with the Teslas and the Leafs and all the cars and stuff, but as universities, we should be pushing this, and I don't think it's that complicated. Somebody just needs to, let's get that bidirectional charge controller at a smaller level.
Okay. So basically you have like little mini generators moving around your campus.
Well, that's right? Exactly what. So when I've built the first two, people say, well, who designed it? Well, it was the team of Kenny, Jeff, and Amazon or eBay, right? We're like, whoa, what's available, right? So after we saw how great the golf cart was and that we have solar power and it stays charged up all by itself, not plugged in, we then bought a 1500 watt inverter, put it in a plastic Caterpillar toolbox, put some jumper cables on it, cut out some air holes in the plastic box, cut out a spot for a 110 outlet, wired this thing all up, and now when we go to events and stuff, lift the seat up, hook up the jumper cables, and now I can run the popcorn machine and the Slurpee, and we have a farmer's market, and sometimes instead of having them run gas generators for the cappuccino machine, we're like, hey, let's just use our golf cart.
Yeah.
Right? And so that's the niche, the kind of cool stuff. But at the same time, if there was a real emergency, I've got a 36 volt generator and I got a 48 volt generator that does 110 volts. I could plug in and run your EHOS, your emergency response center. And if those batteries ran down, even the other golf carts that don't have solar panels, if they were charged up before the event, okay, bring in another one, hook up to jumper cables. The one that we used for the actual farmer's market, we didn't like the jumper cables, so we just used, a forklift, a big plug, so that I don't have interns that are, hooking up jumper cables, right? So we just put a plug on it, like, how you charge up your forklift, and take the toolbox out there, open up the lid, pull the cables out, plug it in, away you go.
No, that's great. I love it. I would have a couple of questions, though. How did you get around some of the safety concerns? I know you're dealing with electricity and students, and it seems like there's some potential issues there.
Yeah, there's a couple issues, but I think to push this technology, we need to start doing this kind of stuff, right? And everything's sealed up, it's got a plug, it's safe. And those are the things that we learned, right? We first did it for Central Plant, where we're all educated, and then it's like, okay, what's the next step,
Yeah.
We bought used lithium valence batteries, and we built a net zero center for student outreach and stuff here, right? Where we took this picnic area that had a lid on it already, put some solar panels on it, put a cabinet in the back with some used batteries, and now we have a big screen and some ceiling fans and an e-gauge, and you can plug your laptop in and see what the energy usage is, right? And all the plugs are,
right.
Things that start to educate other people. So even though I'm the chief engineer and I'm the energy manager, I work at a university. And so if you're on a university, your job is to help educate people, I believe, right? And so how can we inspire the students that have no clue? We're not an engineering school here, but you don't know who you're going to touch on what level. And so I think it's important that we share this kind of stuff with anybody that'll listen.
Well, I love how we were talking about the phase change material. It sounds like it would be sealed up in a box underground, so you're not really going to see it once it's in place.
Right.
But with this kind of stuff, it may not, on the total energy that's flowing through it may be fairly negligible compared to the overall campus, but it's super visible and it's going to touch a lot more people. So it has a completely different purpose, but it's still, I mean, like you said, it's got real utility in really specific cases, which it's way cheaper than running diesel generators or something like that all over the place. So that's great.
Exactly. There's no noise, there's no anything, A lot of things, like I said, that we should be doing are, just because we can't do this giant thing, if we can do it, we should still be able to do small stuff, because you don't know what person you're going to inspire to come up with the next giant thing. Right. And so, another cool thing that we're doing, there's so many, we're doing a condensate recovery, right? Because I have a tunnel system, I have a bunch of air handlers that are in that tunnel system. So I'm able to pipe all of those. And so instead of letting that condensate go down the drain, we worked with a company called Drip Cycle. They developed this. It's so simple, right? But it's like, they came up with it. It's their design. Graduate students from, I forget what university they're from. But we're now taking all that water and we're pumping it through the tunnel. So from the farthest one, it pumps halfway through to another one to a bigger tank. We take condensate from those, and we're just using a little giant to pump it from the big air handler to a tank. Once we get so much in the tank, we pump it farther down the tunnel, and eventually we'll pump it into the cooling tower. We're looking at 1 million gallons a year of condensate recovery.
Yeah, so a little bit goes a long way if you could capture it all, right? Yeah.
Exactly. And so when I did that project, though, I did it with clear PVC pipe. And everybody says, why are you spending the money on clear PVC pipe? I said, well, every year I open up the central plant for tours. And I give students, faculty, anybody that comes in, we spend a day touring the campus, touring the, what does it take to make chill water? What is a cooling tower for? What are boilers? What are chillers? What does an air handler look like? And now how cool would it be as you're walking down through the tunnel and you look up and you hear this water gurgling past you in this clear pipe? You can really tell the story. This is free water that just comes out of the air. Mm-hmm. And when you say that normally we dump 1 million gallons of that down the drain every year, those are stories that we use also to inspire people to do greater things, I believe.
Yeah, no, I love it. Well, Kenny, I'm sure I could talk to you for many hours, and I know both of us have other things we got to get back to today, like running a campus in your case. But I did want to just say thank you for coming on and talking about all the great work you're doing. Any closing thoughts you want to leave our listeners with, and then also ways for them to get in touch with you if they want to reach out?
Yeah, sure. I think you're going to put together some webpage or something, right, with some links and stuff.
Absolutely.
So my email, I would look me up on LinkedIn. I'm the only Kenny Seeton on LinkedIn, I think, so it makes it easy to find me. I'm not a Smith. I love to share on LinkedIn. I love to share ideas. And then the other thing is, like I said, if better is possible, good is not enough. Think about what you're doing, right? Think about how can we get the most bang for our buck out of this widget? How can it work with something else? Those are the things we need to think about. And design to the 90%, not to the 10%. Let's make adjustments for the 10%. Make this world less greenhouse gas, better.
I love it. I learned a lot today, so thank you again for taking the time to come on the show.
No, this was great. Thanks for having me, Dave.
Excellent. Thanks, Kenny. Talk to you soon.
All right.
That's it for this episode. Thanks to Kelsey Harding for her production assistance. Our music is Under the Radar, courtesy of Dallas-based musician and composer Gio Washington Wright and his studio big band. If you'd like to follow our show on social media, our Twitter handle is @EnergyPodcast. You can also find us on LinkedIn. Just search for Campus Energy and Sustainability Podcast. If you'd like to support the show, consider leaving a rating or review on iTunes. As always, thanks for listening.